Okay, here's sort of some visual aids for turning in. This is your aircraft. You're heading to the right on the deck, fast as you can go. Each one of these squares represents 10,000 feet. So this is 60,000 feet, which is 10 nautical miles at 6,000 feet per nautical mile. So this is the enemy aircraft that's pursuing you. So for example, if he's 10 miles behind you at 10,000 feet, then he's going to be about 9 degrees above the horizon. And it's about 9 degrees per 10,000 feet. So you'll see at 20, he's at about 18, and at 30, he's at about 26, approaching 27. And by the time you turn around, you sort of lose a mile, so I just round it to 10. So I say, how high is he above me? What's the difference in our altitudes? And for every 10,000 feet at 10 nautical miles, that's about 10 degrees up. If he is closer to you, right, so if he's at 20,000 feet at 5 nautical miles, then it's about twice as high. So 20,000 feet at 5 nautical miles is about 40,000 feet at 10 nautical miles, and that works out to about 4 times 9, which is about 36, a little bit less. So the reason you need to know this is because the way this tactic works is you want the enemy to get within 10 miles of you, and that's so that your auto acquisition modes will be able to pick him up. Then you're going to go into vertical scan, and you're going to do a hard level turn after making sure you've got your engines back to defeat any heaters that he might shoot at you. And then after you go through 90 degrees of turn and throw off some chaff to break his radar lock, then you need to put the plane of your lift vector on the plane of his altitude. So you need to know what that angle is so that when you come around the corner, you can lock him up, wait for the dot to be in the middle of the ASE, fire your AMRAAM, continue your turnaround, and continue to evade and escape. And if you do this properly, you will really never be vulnerable to one of his missiles while being able to send a radar missile right at him. So now that we have some of this sort of annoying math stuff out of the way, let's go see what it looks like in the airplane.